Good, good afternoon, everybody. Thanks to the Padiglione Italia for allowing us to be here today, and to the many people in the room who decided to spend with us the next 2 hours. I'm Dario Sciunnac. I represent the regional department for University Research and Innovation of Regione Lombardia, and I have the honor to introduce this workshop. Last May, just a few weeks after the Expo Osaka was opened, our regional minister, Alessandro Fermi, intervened on the issue of sustainable innovation in our region, Lombardy, and it is from there that I will take my start. It is widely recognized since the pioneering work of Alvin Toffler and others that there is no future for developed countries without innovation. Yesterday in this room, a memorandum of understanding was signed between our regional president, Attilio Fontana, and the president of the prefecture of Osaka. And they shared 5 points of common interest for the next years. And the first point of the list was innovation of enterprises, especially startups. This is why we think that it is crucial that research and development are co-funded by public investment programs. Within the current investment program for Lombardy, supported by the European Union, in particular the European Regional Development Fund, financial resources are dedicated to support partnership of research institutes, enterprises, and individuals investing in research and innovation projects. The amount of the funds has increased from 380 million euros to 1,512 million euros in the 2 subsequent programming periods. Also, the Recovery and Resilience Facility that was promoted by the European Union as a response to the coronavirus pandemics is worth 18.4 billion euros in Lombardy, 21% of which dedicated to research and education. And our region is also involved in many Horizon, Life, and Interreg projects, although with a much lower budget. On the other hand, we are aware that all this financial effort cannot be enough alone to revert the trend. During the 2014-2020 programming period, only about 2% of the over 800,000 Lombardian enterprises, most of them medium and small, have obtained subsidies from the European Regional Development Fund. This also depends on the remarkable red tape effort required to enterprises and institutions to apply to the calls. Calls are demanding. Subsequent controls can be harsh. And during the 2021-2027, the Green Deal, the so-called Green Deal, has introduced stricter requirements on environmental sustainability. Not all our enterprises are ready to cope with this. Nonetheless, we have excellent examples that it is possible to perform research at the top level, meeting all the administrative requirements, timely completion of the projects, full expenditure of the resources, and respecting the highest environmental standard, also because the extra costs involved are eligible costs. We are aware that just heading groups of our enterprises are ready to face all these challenges, but their example and the better economic performance that they commonly achieve as a result can summon emulation. In any case, an institution like Regione Lombardia cannot limit its range to the distribution of subsidies, however important they are. Research and innovation are supported also through a regional policy involving experts, in the Regional Forum for Research and Innovation, as well as laymen through public consultancies on the web platform Open Innovation, through periodic plans and programs, and even more interestingly, through cross-cutting organisms like the Lombardian technological clusters. Namely, those clusters are the protagonists of this workshop. Over time, 10 technological clusters have been established in Lombardy, each of them gathering tens of research institutes, enterprises, and organizations involved in research, innovation, and development. Each cluster matches at least one of the priorities of the innovation of the smart specialization strategy, the so-called S3 of Regione Lombardia, a policy instrument requested by the European Commission as an enabling condition for financial support through the ERDF, spanning from life sciences to aerospace, from chemistry to manufacturing, from environmental sustainability to smart mobility, etc. All clusters with a limited financial support from the regional government, and mostly self-supported, manage system action in a triple or even quadruple helix perspective, aimed at enhancing dialogue among different stakeholders, technological transfer between academia and enterprises, more effective participation in projects, a more successful application to the available European, national, and regional funds. They also favor the convergence of regional policies and emerging industrial or research trends through specific roadmaps, bridging the gap between institutions and enterprises. In the present workshop, 2 Lombardian clusters will hold the stage, the Lombardian Smart Factory Cluster and the Lombardian Green Chemistry Cluster. I will take no extra time with this introduction. Each cluster can present itself much better than I could do. So I'm leaving the floor to the first cluster, the Smart Factory Cluster, AFIL in Italian, Associazione Fabbrica Intelligente Lombardia. And I wish you all a profitable workshop, welcoming you in the world of the Lombardian Technological Cluster that, in my opinion, represent a viable model of structural and institutionally driven collaboration that could reply in many other developed countries. Have a nice workshop. Thank you.
Thank you, Dario, for the introduction. And it's my role to activate the 2 parts of this first session of the workshop. My name is Marcello Colledani. I'm a professor at the Mechanical Engineering Department of Politecnico di Milano, technical school in Milan. And I'm representing AFIL, the cluster on Smart Factory that was mentioned before. It's a cluster of companies, small, medium enterprises, but also large companies in Lombardy, comprising about 150 companies on the territory. Very focused on innovation and also on sustainable innovation, as you will see today. I will be concretely presenting the results of 2 projects and also trying to make them open for cooperation, of course, with your companies, your institutions, but also to create curiosity on the results in the non-technical members of this audience in order to foster the uptake of these solutions at social level as well. The 2 projects I'm talking about are part of a program that we have in Europe, which is called I3. I3 stands for Interregional Innovation Investment, which basically means creating a collaboration of ecosystems among European regions for fostering innovation, transferring of research results to industry, and of course, enhancing the capability of companies to invest or co-invest in making this innovation real products, real processes, and real technologies together. Now, First project I will be talking about, and after me there will be companies presenting their own results, is called DERENCO, that stands for De- and Remanufacturing for Composite Materials. I don't want to go technical in this session. You will have some samples in the back of this room. We will have the chance to continue the discussion more technically afterwards, but we are talking about a set of extremely good, extremely widely diffused materials, which are called composites, which are also called fiber-reinforced plastics. And these materials are very widely adopted in some of the most common sectors: housing, construction, energy systems, wind blades, for example, transportation, transport, trains, automotive, but also sport equipment. Skis, for example, are made of GFRP, although users usually don't know that. So it's a really wide set of materials that are well substituting metals because of their lightweight performance. So they are light. They are light and equivalently resistant with respect to metal. So very nice materials with only a single issue, that is bounding their market diffusion still, and there are companies working in this sector are struggling with that. There's no clear route for this material after the use phase. So you buy the product, you use the product, and then there's no real established solution for recovering materials or regaining some value from these products after the use phase. And this is a challenge because today they almost all end up in landfill, at least in Europe. I think the situation here is kind of similar for these materials, and worldwide there are not too many other solutions. So just to give you one number, wind blades, you know, these very large blades that are used in wind systems, they are becoming larger and larger. Today they reach 100 meters. So imagine 100 meters of glass fiber reinforced plastics materials, and the Wind Europe Association predicts that 70,000 tons of this material after the use phase, because now they are starting changing the original wind systems, are getting into waste in a few years. So this is a problem and an opportunity. In this project we are trying to see this as an opportunity. So we are putting together many competencies of research centers, companies, design studios as well, because a lot of interesting things can be done with design, as we will show, it will be shown later on by my colleague Matteo Rigoni. And all together trying to find possible routes for reintroducing these materials into new products. We are not, of course, developing the old technologies in this project. We are based on available knowledge on a previous project I coordinated. I mentioned this book because it's open access, so you can download it for free if you're interested to go more in details of the technology. But let me show a little bit what we do, and then we'll open the discussion later on to the industrial partners. We are following two main approaches. The first one is a very basic idea. So if you cannot reuse the material after the use phase in the same application because of loss of technical properties, why don't you use the material for other applications that are still valid, valuable, but require a little bit lower mechanical properties? So what we call cross-sectorial circular economy applications. And of course, this is very useful, especially for the downstream sectors that reuse these materials, because they can reuse secondary materials instead of new materials. And you can imagine how much can be saved in terms of environmental impact and emissions. The second key principle is what we call the demand-driven circular economy. I don't know if you are familiar with recycling, but many times recyclers, what they do is they have a system, recycling process. They take the material, the product, they apply their process, and after the process they have some material. And only then they ask themselves and to the market what to do with this material. And the answer many times is nothing, because the material lost its property. So we are trying to reverse this principle, to say, okay, what we want to do with the target material to gain some value from the material properties, and how to pull the specifications on these streams in order to adjust the recycling process and make it possible to obtain continuously this material in specification. That's what we call pull system or demand-driven. I think I have to go quicker with this introduction, so I just briefly mentioned the two strategies that we're implementing here. One set of cases that you will see is based on the mechanical recycling. So we basically reduce the size of the input products. Here you see what we do for the wind blades. And every different fraction has its own reprocessing technology that can be fed with this material. You will see some example later on. The second route that we are using is a completely different process, is a thermochemical process. We are trying to liberate the fibers from the resin, from the plastics, and then these fibers can be reused for other applications, as you will see. More expensive? Yes. More energy intensive? Yes. But for example, for carbon fibers, it enables to obtain quite good material that can be reused in new textile, for example, as you will see. We have 14 industrial cases here, applying these two strategies in different input products and different target sectors. And some of these industrial cases, I would say probably half of these industrial cases are super mature and will go to the market next year. So if you feel that we can create a cooperation here, please let us know and we will be glad to investigate how. The second project that we'll be talking about is still on circular economy, but is focusing on another very strategic component, batteries. I mean, we are in Japan, so batteries are important here, and you have been pioneering this sector. And really, I think that you gave a great boost to the electromobility market, thanks to all the activity that has been launched here. In Europe, we are now considering the possibility of regaining some of the materials from these batteries, because as you know, we don't have so much production of battery-grade materials. We import basically all of them. And we are actually starting the production of batteries because we have projects of 25 gigafactories, but this is very recent. So concentrating on what to do with the post-use batteries in our electric vehicles, it's something that is of premium importance. In this project, we are collaborating on trying to find the problem of recovering materials from these objects. These objects are complex electrochemical structures. So I call objects, but in fact, is a mix of solid, liquid materials together, granular fractions. And what is most interesting usually is the cathodic fraction that is a granular fraction. So not easy to get to the pre-concentration of these materials. This is a project that, of course, Lombardy is not only doing itself, it's again cross-regional, so you will see partners from different regions, although the partners that we'll present here are from our region. There is quite a lot of investment in France as well in this project. We have Vercors, one of the first gigafactories in Europe, and Orano, one of the largest recycling facility in France and in Europe to get in the project. And the different strategies that we are trying to apply, of course, encompass the entire circular value chain, from the disassembly and safe collection of the batteries, Christian will be talking about this today, to the possibility of applying second life processes. So what does it mean? Trying to regain the battery cells to produce new batteries from different applications. We have two cases there. Down to the chemical pretreatment, a mechanical pretreatment and chemical refining process done by Orano, and finally, the reuse of the materials, battery materials, into new batteries. So we are really trying to demonstrate the closed loop activities around these complex materials. I think I finished with this first part. I hope I didn't take too much time. Just wanted to give you a little bit of highlights. My colleagues will go more in details of each use case. And well, I don't think we take questions now, but I can move directly. Now I change my hat, virtual hat, because I don't have any hat, but I change it virtually because I take the role, I better don't touch this, I take the role of founder of a startup, which is called Fiber Use Tech. That's not the right slide. Fibrous Tech is a startup we funded after the project that I mentioned, Fibrous, that I'm talking about composites, right? That's the first part of our next 45 minutes. And yes, perfect. And we founded this startup and we started cooperating with other companies. And I will talk about now a very specific case within our Derenco project, which is based on automotive BMC production with recycled glass fiber granulates. BMC is an acronym for bulk molded compound, and it's a special type of materials that are very widely used in the automotive sectors, but also in electronics. And I will explain how we did make it possible to include granulates, recycled granulates from wind blades into this material and still produce very good quality automotive parts. So this is one of the demo cases of strategy one, the one based on mechanical recycling. So we basically apply processes to obtain granules that then are mixed of fibers and resins and can be remixed with new plastics, resin, to obtain new compounds that then are reprocessed for obtaining different parts. And I was talking about this specific application to automotive industry. In this case, we take both end-of-life wind blades materials, glass fibers. We take BMC scraps of the company that I will mention in a second, and we recompound this material, and we obtain these automotive parts that you also have on the back as samples with very good mechanical properties, equivalent to the parts that only use virgin materials, but with recycled materials inside. So much more sustainable for the sector they will be introduced in. Two companies are collaborating here. One is NTS. NTS is a company close to Milan in Bergamo. They have been working on molding and plastics molding for automotive since many years. You see, founded in 1959, so it is one of the typical high knowledge intensive SMEs that we have in Lombardy, right? And they have been producing parts with virgin materials for years, and now they will be starting producing parts with recycled material inside, thanks to this project. And the other company, I was saying, our startup, Fibrous Tech, is a startup that we founded in 2023, also received one prize from the Lombardy region, the Startup prize, and from the AT manufacturing in Europe. And we have a patent on controlling the mechanical recycling processes to obtain granules for being reprocessed in different applications. So together, we have started investigating this case of reusing BMC, using GFRP materials, glass fiber reinforced materials into BMC to obtain this recycled BMC. Let me just take a few minutes to show you how we do it. We first collect the blades. We cut the blades into smaller pieces, as you have seen, and then we shred in 2 or 3 phases this material, obtaining these mixed granules and fibers, this resin and fiber granules. And then what we do is we recompound. What does it mean? Well, probably the next slide will show it better. Recompounding means that we remix this material with the virgin fibers and virgin resin. Of course, you need to calibrate the receipt very carefully, depending on the application. And you obtain that kind of, it's called BMC material, that then you can re-inject into molds for producing various shaped parts with very, very good mechanical properties and very good aesthetical properties as well. That's basically the process, so it's not that complex, but it's mature. And of course, what is complex is to calibrate the parameters of the shredding process and the compounding process. But as you see, we are not changing the production chain of the company. We are not requiring the company to go for high investments. We are requiring the company to fine-tune the process. That's what it is. Results are pretty good. We have been testing all the parts. Again, if you have time, just see the sample later on. The testing show comparable performance, and in the automotive, as you can imagine, is extremely important to provide parts with secondary material because this decreases significantly the footprint of the whole vehicle. That is the main challenge today for automotive companies. Here you see some of the samples we have been bringing to the JEC in Paris. JEC is the most important composite exhibition in Europe, worldwide, I would say. And you see some of the products that we also brought to the Milan Design Week, because as you will see just after me in 2 minutes, design is super important also for these technical products and to valorize the material. Of course, there is a business case behind. Some of you were asking me about the business case or the cost of this material. There is a positive business case behind, and as I was saying, the company is now in the process of getting this product certified by the automotive supply chain in order to enter the market because there is a strong demand for these products. So the first case that I wanted to show you is very technical, I know, but we are in Japan, so automotive is important, so we thought it would have been important to show that we can definitely cooperate in this very intriguing area of embedding secondary material into new parts. I will stop here with the first demo case, and again, if you have questions, maybe later on we can take them. Yeah. And I will give the floor to my colleague, Matteo Origoni from Origoni Steiner Studio, that will talk about the role of design in creating new products embedding these materials. Thank you very much.
Good morning, everybody. Thank you to be here. And thank you, Marcello, for introducing me. I am Matteo Origoni from Origoni Steiner. We are partner of the REMCO project. And, well, waiting for my slides. I'm sorry if you want to come here before me. And anyway, we are a design studio founded in 1980, based in Milan. And just go to the next slide. OK, perfect. So here we are. We are a design studio basically focused on exhibit design and communication design. That means that we use design to communicate. So video design, product design, graphic design, interior design are tools to communicate for us. And that's why we participate to the REMCO project. And for our demo case, we have a strategy and an object that is to bring new design product and materials and semi-finished material into the market. And for this reason, we are trying to realize new interior products and exhibit elements which can replace the ones currently sold. And the main goal is to reach the market with new attractive products and with a strong storytelling that can be received by different stakeholders like producer, seller, and of course, final user. And to do that, we are stressing all the aesthetical and mechanical potential of the recycled FRP material using different methods and reprocessing methods to create different products. So the innovation consists in offering design service for circular FRP furniture and temporary elements to introduce them to the market. And about the furniture, we want to give new life to waste material, avoiding the disposal step. And about the exhibit element and temporary projects, the goal is shorten the process change for crafting temporary exhibition elements, given the opportunity to close once again the process change with an additional route, so from collection to remanufacturing again, which can close the production cycle and give economical and logistic advantage. So the first step in this direction were about material testing. So during this work, we are not a producer, so during this work we work with fiber stack, testing various formulations and realized plant sample. You have the sample there, so if you want to touch and test it, you can do it later. And we tested various formulations and realized plant samples to verify the KPIs needed for a good creative products. And for the test, we use a different material and reprocessing methods to guide the design process and achieve the better possible results. So the first results we obtained from wind turbine waste have highlighted several problems caused by the size and the quantity of the material. But the most promising result was achieved mixing the wind turbine recycled material and the NTS recycled BMC presented by Marcello right now. So with the test D, for example, we reach uniform and smooth surface with different shades and textures that could be very interesting to create new objects. And after several other tests conducted with different recycled material percentage and origins, we achieved a very good result with the test, the L test, you have it there, made by compression mold panel with low pressure, with good mechanical qualities, different surfaces on the two-phase and easy boarding. That is very important to produce a plane, for example. And we also introduce a color pigment to change the color of the new material. Right now, about the design activities, to drive these kind of activities, which is strong linked with the first one, Politecnico gave us the opportunity to develop a new custom manufacture set for the mechanical engineer department. The purpose is to redefine the spatial use of the polymeteras through different furniture typologies conceived as both functional objects and tangible demonstrator of the FRP recycling results. The area is a very important area because Politecnico building is a part of a new big urban plan which involves construction a university, a very big university new park. So in the future, this could be the chance for us to show the recycled FRP potential through a public furniture elements to characterize the university spaces with innovative products. So the furniture system, to conceive the new products, we imagined a flexible furniture system which, starting from a series of modular elements, could be configured in different shapes and forms. Regarding the terrains, the need was to define different islands, defined by tables and umbrellas surrounded by plants, where the public dimension of this space can be perceived as an intimate and welcoming space too. This is a render of the island mentioned before, with all the different pieces. And these are the seats. All the furniture elements have been designed to minimize the mechanical joints. That is a very important point for us. And that's why it's going to be easier, a future collection of the end-of-life products, so we can reprocess the object again when the object ends its life. There is a stool and a chair, redesigned in the last version with some holes to make it lighter, and made up of two mold casting parts, which allow us to different color mix configuration for the same objects. This is the prototype we show in the design week. So the prototypes highlight the material surface, edge, and colors. The holes make the object lighter and more practical. and the waste material obtained during the production can be reused then. So this is another important and key point for us. The deck chair design follows the same constructive and formal principle. It's made by two different molded elements, expanded the seat surface to get a more comfortable and relaxed stay, and to achieve an ergonomic shape to use it better. This is the prototype, and again, the material quality is highlighted by the prototypes, and it's resistant to pressure and tensile stress. It's very important to know also to test the mechanical capabilities of the material and of the objects. Holes and folds make the object lighter again, more ergonomic, and the section and the joints allow us to place several objects side by side in order to be able to obtain a strong long bench. Public bench in this case. And then the table, it was quite complicated to do a table with this kind of material because of the weight of the material, but anyway, we change many times the forms because the forms are directly linked with the compound, so we had to do the work in the first phase in order to design the pieces then. And the support now is by 4 equal symmetric legs produced with a unique iron mold and joined by a central beam. The beam and the plan, so the structural elements were produced with an open press mold to obtain a beautiful and homogeneous surface. Sorry? Okay. So the prototype highlights the material strengths, and the geometry of the legs give it a sense of light and make it formally consistent with all the object series. And the top, the surface makes it more interesting and suggests that it was created from a circular material in this case. These are the pods. We had a lot of problem about the pods because it's a simple geometry. It's a triangular pods. But due to their geometry and weight, we are changing it, and we are trying to introduce a new compound with a lower density and some kind of glass bubble inside to make it lighter and to attain a better results. These are the prototypes. At the same time, we are conducting a test on the design phase to realize a pot with different elements obtained by a single flat mold, which can be assembled using metal joints then, like for the other object. So this aspect, the relationship between the design aspects and the compounding are very important for us because the form of the object is strong linked with the process steps we have to follow to create it. This is a render of the island, and another one with all the prototypes or objects we want to produce for the Politecnico to show the result of the Remco project. And, well, first, this is the potential customer and market because we want to involve, to do this work, our current customer in the furniture field, but not only. We want to involve also new customer to enter in the exhibit and temporary sector. So the main possible target markets are interior product, temporary and exhibit products or elements, exterior furniture, of course, and interior finishes, like, for example, walls or interior finishing. This is the circular, that's why the result of the Remco research were exhibited in the Milano Design Week 2025. A completely circular exhibition was created for this occasion. all the display elements we create were designed and used only two materials. So fiberglass laminates, commonly sold on the market, and the aluminum profile system commonly used in the industrial environment to create machinery supports and enclosures. So this is the master plan of the exhibition. There were a big area at the entrance dedicated to waste material, preliminary treatment, and semi-finished material in order to present the real work of the Remco. And then the visitors were invited to follow a circular path to watching the prototypes, all the prototypes, and they were forced then to return to the starting point, so to the end of life products, to understand which are the main topic of the Remco project and the circular economy. This was the entrance, so some slides to present the exhibition, the entrance with all the graphics we designed to create a coordinated image for the Remco in order to present all the demo case, not only the design demo case. So this was the main area to present the finished material, the semi-finished material and the process, and of course the waste. Some detail about that. And
I need to urge you to conclude.
Sorry?
Yeah, I need to urge you to conclude.
Okay, no, we are closing it. Some more photos about the exhibition and the different results, the NTS result too, our results, and then a consideration to close because all the installation must be removed at the end of the show. So in our case, all the structure, the metal structure, the aluminum section profiles were dismantled and will be reused many times because end its life in a landfill, and the same goes for the video, the audio, and the lighting system. So all the fiber panels were returned to the Polytechnic, and thanks to the technology developed during the project, the entire project, have been reprocessed into granulates again, which will be reused to produce new objects and hopefully new exhibition. And that's it. Thank you. Thank you again.
I can give the floor to Giorgia Zanchin from Centro Cot to conclude the presentation of the project stemming from the Remco. Please, the floor is yours.
Thank you. Thank you for the introduction, and thank you all for being here. I'm a researcher at the multi-lab department of Centrocot in Italy, and today I will show you some results regarding obtained in the framework of the Remco project, but starting from the thermochemical recycling of the composites material, and in particular regarding technical textiles. Okay. Professor Colledani already presented you which are the challenges connected to the composite material, and in particular regarding the possibility of recycling this material into something that is useful and with keeping a high added value. I would like to add another challenge that is more connected to the technical textile sector. Technical textile products is something that is engineered primarily for their functionality and performance. And basically they are used for automotive, safety and construction sectors. At the moment, the market demand is increasing. And together with this, the possibility of having more sustainable material, but that still hold their functionalities. Together with this, in Europe, and I think all over the world, we are facing with another big challenge connected to the textile sector, that is the waste management of end-of-life products. There are many research and documentaries about how the textiles and all the apparel and clothes that are at their end of life are disrupting our environment. So in our work, we tried also to tackle this problem. And this is how we try to put together these two challenges and find a systemic, cross-sectorial, and also demand-driven solution for composite recycling, considering also technical textiles and textile waste. Our idea was basically to generate a synergy between two sectors that generally do not cooperate, like the textile and the composite sector, producing something that can be used as a technical textile. So the input material were glass fiber and carbon fiber reinforced plastics after pyrolysis, together with thermoplastics polymers coming from the textile sector. And the output product are hybrid products containing containing carbon fiber or glass fiber and textile. How we did this transformation from the input to the output materials, we tried to find some processes and technologies that are already applied in the textile sector, and we checked if they can be enabled to be used for this purpose, eventually optimizing them for the materials that we were working with, such as considering the length, the strength, and also some specific characteristics of the materials. I will show you now some results, and in particular a result regarding the production of a hybrid filament. And you can see also at the end of this session, behind you there are some samples. In this case, the input materials were carbon fibers from pyrolysis that were previously reduced in dimension. So this is the starting point, the carbon fibers from pyrolysis. And as you can see, they are quite short fibers, and they are very similar to fabric fibers. So we decided to mix them with recycled polyester and applied all the technologies typical of the textile spinning. So after mixing with a different composition, we did the spinning, we obtained a sliver and later a roving. But for this material to be used for a practical application, we decided to embed it into a polyester rope in order to have some practical applications and avoid contamination and the release of the fibers during the use. Here you can see some products realized, and since we are a technological testing center, we also characterize this material. And the analysis demonstrated that the core of this rope that is made from 70% polyester that we know to be recycled because we keep the traceability of the materials along all the recycling process. And 30% of carbon fiber, while, as I previously said, the cover is just made from polyester because of practical applications. The diameter of this rope is about 5 millimeters, but the interesting part is the mechanical properties of this rope. The braking force is more than 1,600 newtons. That corresponds to more or less a load of about 160 kilos, so quite a lot. And the elongation at brake is more than 43%, is around 43%. This corresponds to a high strength and elastic rope that can be used for many applications, such as sports, protection, and construction, and many applications, because this rope can absorb a lot of energy before braking, and also demonstrating quite good elasticity. But let me tell you a couple of words of who did all this work. Centrocotta, as a technology provider for the Remco. Centrocotta is a company that supports companies of the textile sector along all the value chain. We are located in Busto Arsizio. It's a city very close to Malpensa Airport and close to Milan area. And this city was once renowned for its cotton production, so we kept with this topic. Here in this slide, you can see some numbers about last year, so just to let know who we are. But I'm a technical girl, so I prefer to go on describing you what we do, like in in our daily activities. We do a lot of testing and measuring. We have more than 2,000 tests available. We produce certification for personal protective equipments for we can release certification like the Ocotex certification. It's pretty a European one, but it's quite famous. We do also some trainings for companies and for young students, and we do experimentation in particular in our multi-sectoral laboratory that is able to support companies. They try to tackle the topics related to circular economy and sustainability. We focus in particular on new materials, in recycled products, in processes for recycling waste material, and also digitalization through a dedicated platform for recycling, for matching recycling technologies with waste materials. So how did we work within this project? First of all, we checked if there are some technologies in the textile sector that can be applied to fibers from composites. We do a scouting for seeing if this technology can be used for the specific materials obtained, and finally we did the test to check also the feasibility, the technical feasibility, and the real products that can be obtained in order to have something that has a high value in the end. And the results was the technical validation of materials, products, and also technologies. We kept in mind during all these activities that it should be something that is demand-driven, so something that the market needs. And behind finding new recycling solutions. And for this reason, we choose to produce a hybrid filament and also some other hybrid products containing these fibers. And what we demonstrated with this demo case is, first of all, the technical feasibility, the possibility of integrate some synergies between different sectors, and also creating new partnerships between different companies that belong to various sectors. Looking ahead to the future, which can be the expected impacts, for sure the creation of a new circular value chain, waste reduction because we both use used textile and used composite materials, products with practical applications, such as you can see a net behind you, but it can also be used for packaging, construction. The environmental assessment is fundamental because recycling should keep also in mind that the reduced products should also have a lower environmental impact. So life cycle analysis is ongoing. And also, we kept in mind the economic opportunities that can be derived from these products. This is just some conclusion. I'm available later if you have any question. But to conclude, I would like to thank my colleagues, Omar and Donatella from my company that hardly work on this project. And thank you, Region Lombardia and AFIL for organizing this event. And thank you all for your attention.
For your communication. Now it's time to describe the second project, which is BETMES. To do that, I leave the floor to Cristian Gullino of ERP Italia Servizi.
And here we are. Thank you very much. I'm very happy to be here, sincerely speaking, because it's not common for us, especially because, you are, for example, my colleagues in the other projects are very focused on technologies development and so on. We are a very human service company, especially we are developing ERP is the acronym, first of all, of European Recycling Platform. We are a service company that especially led the activities into the environmental field. So the consultancy in sustainability, in circular economy, and of course in waste management and so on. But today it's very interesting to, as I say, to be here to explain something different that it represents for us a change of our strategy by attending, for example, BATMAS project. BATMAS project, as Marcello explained just before, just at the beginning of this meeting, is a project focused on battery management, end-of-life battery management, and battery recycling and reuse, and so on. But why we decide to attend to this project? Just because we said that yeah, the battery is something for us very important and was something that highlight the real necessity to change a little bit our habits and our way of life. And in fact, as you can see here, recent global events have really highlighted the limits of this linear economy model that is here representing in this scheme, in which all the environmental part, all the environmental activities are unfortunately put aside in a very side moment of the life cycle of a product or a service and so on. So we decided to attend this project to try to change a little bit more this paradigm, and then to promote circular economy thanks to our skill, thanks to our 25 years of experience in this environmental field, for example, in collection and compliance in terms of environmental needs. And in fact, thanks to this, our forma mentis, let me say, we decide to try to design and develop something in terms of services, starting from the collection of an end-of-life battery, and then to give the opportunity to this end-of-life battery to achieve more added value in terms of recycling, reuse, and refurbishments, and so on. So, as this slide is saying, is supporting the strategic value chain and supporting the implementation of the circular economy model, a truly circular economy model, in which, for example, all the stakeholders linked to strategic value chain like those of the battery are really interconnected together and then can collaborate together in a same environment in order to influence each one with their competences, with their knowledge, and so on. Here, for example, you can see, as I said, circular economy is quite a little bit complex to, if compared to the linear economy model, because, as I said, there's a lot of stakeholders to be matched together. But European policymakers, for example, starting from the Circular Economy Action Plan in 2020, that was a very interesting starting point, especially at the environmental level, has given us the opportunity to start with implementation with this circular model. And especially, as is proved in those lines, on the top of this slide, EU policymaker regions and, of course, association and other subjects join forces together to drive circularity across strategic value chain. And here, the value chain, strategic value chain, is those of the battery. Some results, fantastic, in the last few years, for example, we can say that the interesting result was, for example, the implementation of the battery regulation that came in force officially in August 2025. That is a result coming from the application of the Circular Economy Action Plan and then changes in this case into the regulatory framework. Some very interesting, like we are talking about I3 project, European funded project that are absolutely part of this strategy in circular economy that push, for example, the advanced waste management project, especially linked to or pushing reuse and refurbishment technologies. And of course, all the project has been designed and implemented to reduce especially the fragmentation of the key technology enabler in Europe. So, a few words about BATMAS, and then I let the floor to Caterina that will explain a little bit better the technical and technological part of our project. What does represent Automat, and how we put together all the activities in order to achieve circularity. BATMAS, as I said, is a circular enabler and want absolutely to support the battery value chain in terms of safe and sustainable growth by maximizing resources efficiency and minimizing, of course, the environmental impact through demonstrable policies, best practices, tools, and collaborative and especially digitized networked models. Now I let the floor to Caterina to explain the rest. Thank you very much.
So good afternoon, everybody. Now what I'm going to do is to tell you how we are going to do at BATMAS as ERP. So about the objectives of the BATMAS project. The BATMAS project in our part is divided into two different parts. One is the APR-based digital platform, and the second part is about the modular safety packaging. So what are the objectives of these two different parts? The first part, the digital platform, the objective of this part is to design and activation of multi-purpose, multi-use and multi-user platform. And after we are going to describe this platform. And some of the objectives of the modular safety packaging is to design a modular battery packaging to meet some safety requirements with some different active system with sensor and some different extinguisher. About the digital platform, these are the different objectives of the platform. It will enable close interaction between the battery valley and its stakeholders. And the platform is divided into two different parts. The first part, the first section, is about the regulatory analysis and the regulatory services. And the second part is about the operational services. The section 1, so the part of regulatory analysis and regulatory services, is about the creation of and use of online courses that are accessible to the user of the platform. And in particular, these courses describe all the directive and normatives that we have to comply with. So this is a very important part. We have 3 different levels of access. And there is also the possibility to create different learning nuggets that are some small extract of knowledge that are available to all. About the second part of the digital platform, this is an operational services where you can have all the chain from the end user to the recycler of the different end-of-life batteries. You can create an offer, you can organize the transporter of these batteries, and then you can have the traceability of your battery from the end user to the recycler. So behind the digital solution, we have an advanced packaging. We have developed this packaging. This packaging have 4 different characteristics. It will be modular, lightweight, with light, inert, and fire-resistant modules, fire control system, and different detective sensor. What we are developed in, you can see it in the first picture. This is the structure of the packaging that is divided inside in 4 different parts, so you can transport different many batteries. The structure of the packaging is in HDPE with some different coat, some different painting, intumescent painting to help the structure of the packaging. What we are going to develop are different gels to prevent and to help some fires if it occurs. These gels are composed by different extinguishing agents, and we want to put this different gel inside the packaging to help the batteries when some thermal runaway may occur. We have also different fire control system and sensor to put inside the container to transport the battery, to control these different phenomena that can occur, so the different temperature and different gas emission. And at the end, we have directly linked between the packaging and the digital platform. So we can put a QR code outside the packaging, and if you scan the QR code, you can go in the platform and have all the data related to the battery that you are going to transport. So that's all. Thank you.
Thanks. We think to have a Q&A session at the end, so I will speed up with the next speaker, which is Professor Colledani again on the safe and sustainable on EcoCirc, the contribution of the EcoCirc initiative to the BACMAS project. Please, Marcello.
Yeah, thanks Dario again. I mean, you have seen 2 projects, DIRINCO on composites, now one of the pilots of BACMAS, the 2 projects that I coordinate at European level. But of course, these projects have been possible, have been promoted by interesting and very important for us action that the Lombardy region has started a few years ago. So I will tell you a story about this cooperation between our regional institution and our universities in Lombardy, targeted to support our companies in making a transition to more sustainable business cases. That was exactly the objective of EcoCirc, that is infrastructural building oriented initiative that has been launched by the Lombardy region. Very briefly, we have understood, I mean, we are dealing with different materials, composites and batteries that are very important in this transition to the e-mobility sector that we are living today in the automotive, but not only, also in stationary applications. And of course, batteries are important elements. Yeah, this is what we established to contribute and to support our companies to make this transition toward more sustainable business cases in the region. We have created a network of universities. You see here it was led by Politecnico, but there were other 5 universities, well, we were 5 in total, other 4 universities and research centers in Lombardy. And together with the Lombardy region, we established this collaboration that was targeted to the idea of enhancing our technological capabilities to help companies to test, to co-develop solutions before they were actually ready to bring this solution to the market. And we focus on different components on the e-mobility. I mean, you see here the components that we have been focusing on, batteries, but not only, mechatronics, e-motors, for example, electric motors, technology plastics and composites, and lightweight alloys for metal sheets in cars. And in these 4 streams, we developed, co-developed with technology providers in the territory machines, equipment that could demonstrate the feasibility of circular processes and then potentially in the future being established in our end users, in our companies. I will briefly comment about these solutions, focusing on batteries, because that was probably the most important value chain we actually investigated and we developed in this action. I didn't mention the amount of money that Lombardy region invested, but Dario knows it's very important, so I will mention that it was 5 million euros of infrastructure. And it's very good because it was very complementary instrument with respect to European projects, right? Really focus on infrastructure building. On lithium-ion batteries, we put together the competences of 3 institutes, National Council for Research Institute on Automation, Politecnico di Milano, and the University of Pavia that will talk just after me, presenting their own part. And together, we have been following the entire circular value chain in batteries. So from the pack disassembly from the vehicle, into the module disassembly and cell pre-treatment for recycling, down to the end material, so the cathodic material refining and potentially preparation for reuse in new batteries. I have to say I'm going technical now. I hope you don't mind, but not too much technical, but a little bit technical, because we are talking about machines. So definitely when we talk about machines, we have to show a little bit what we have been developing in terms of robotics, in terms of solution. So this is what the CNR has been developing, a robotic system for disassembling batteries. The batteries that you see, well, you don't see because they are in the lower part of the car, but they are embedded in your car. So they need to be disassembled before being treated profitably and safely during the end of life of the battery itself. That's exactly the goal of this robotic cell developed by CNR. And then it comes our part at Politecnico when we have developed a cell for testing and cycling the battery, try to understand if the module that is extracted by the pack can be reused as such, or should be further disassembled for obtaining cells that potentially could be reused. Or even the cell cannot be reused, and then we need to go for recycling. That's the key idea of this testing facility. And then we have co-designed with different companies, again, in the regional territory, the next steps. So we have a semi-automated module for disassembling the cells from the battery module. And then, I would say first, robotic cell for cutting the cell case and extracting the inner winding. So this is probably what we probably the most, let's say, different step with respect to what other companies are doing and other research centers are doing. So we don't process directly the battery cell, but we separate the case from the inner winding where the key material is. And the reason, well, you will understand later on why we do that. And finally, we have a facility for shredding the material and concentrating the black mass. So the output of this process is a very pure black mass because you don't mix the steel of the case with the internal winding. Well, I don't want to go too technical, as said, so I won't explain these graphs. The idea is that, of course, by testing and cycling the battery within this kinematic chamber, you are able to understand what is the residual capacity of the battery itself and what is the residual useful life if you would reuse that battery. And with these two information, you can know whether it makes sense or not to think about the reuse of that battery itself. This is what we do in disassembly. I mean, we have been testing different disassembly methods for separating the cells from the bus bar in the module with different geometries. I mean, I could speak for hours about the complexity of this problem. all batteries are, all modules are very peculiar, specific. There's no standard. So if you want to have a flexible system, you really need to decide very carefully what is done manually, what is done automatically, because otherwise the risk is that you remain stick to a specific model and you're not flexible at all. That was the challenge. And the kind of system we have developed is sort of compromise. Some operations are manual, some are automated, so you can combine safety and flexibility to treat different models. And last but not least, I was mentioning, I will skip this because of time reason. I was mentioning the cutting process. Yeah, I would say this is first ever machine that does the automatic cutting of the cell case, as far as I know. We have not patented the machine, so I mean we are really prone to collaborate, happy to collaborate if you want to on this technology. There is space for improvement in terms of cycle time, especially. So basically, there is a robot that keeps the battery and brings the battery to a rotating tool. It's a mechanical cut. And through a programming, the robot cuts the case of the battery, and then by rotating the robot, you can have the inner winding fall. But of course, the inner winding is is embedded in liquid electrolyte. So if you leave the electrolyte in the environment, it will evaporate. So we need to capture the electrolyte in order to avoid this to be diffused in the environment and treat safely the remaining part of the battery. That's, in a nutshell, what the machine does. It's in our lab, so whenever you are in Milan or around Lombardy, we'll be happy to show you the technology. And last month, well, there is a video somewhere, but I think it's going to be too slow, so maybe we can skip it. But of course, this is not a real battery, it was a sample. But now we are treating real batteries, of course, in our lab. And then, last but not least, you can regain the inner winding that you see here. You can shred the material. At that point, you don't have the strength of the case, so it's much easier to shred the material. You concentrate the black mass. And the graph that you see there, well, you don't see, well, you barely see on the right, gives an overview of the different fractions that you obtain after sieving. And the black mass that we obtain is very pure in cobalt. That's the most interesting material in NMC batteries. So it's promising. It's not that impactful. Really looking forward to continue the discussion on this topic that is also part of BATMAS project. This is what Pavia does, but I will just stop here and give the floor to a stakeholder from University of Pavia that will tell us more in detail what they do on the remaining fraction of the battery, the black mass. Please, Riccardo.
Thanks, Marcello. So we leave the floor to Riccardo Morina, who presents sustainable chemical recycling of cathode materials from post-use batteries in collaboration with Professor Eliana Quartarone, who unfortunately wasn't able to be with us.
Thank you. Can I ask for the presentation? That's mine. So I will start by introduction myself. So thank you for the introduction. Yes, my name is Riccardo Morina. I work as a product manager from ERP Italia Servizi. I am a PhD chemical expert in the field of recycling of lithium-ion battery. As I say, this presentation was done in collaboration with the Professor Eliana Quartarone. She is a professor of the University of Pavia. And some data that I will show today to explain the concept of the recycling technology and how we are actually, not only in Europe, but also in the research global field, I will be helped by some results obtained from R2BAT laboratory. So first I will start with a really quick introduction that was also mentioned from the previous speaker, why we are going to talk about recycling of lithium-ion battery. Well, as you know, for a preparation of a lithium-ion batteries is requiring a different type of critical raw material. And from the Critical Raw Material Act, quite all the elements that are requiring are considering for Europe critical and strategic. And for the continuous increasing on the demand of battery, especially to the continuous increasing of EV market, it's really important for the Europe to find a new solution, maybe more environmental, more with a less environmental impact in order to obtain their own critical raw material. In the last year, European Union have already proposed a different framework in order to give some way to and some target to be obtaining and reach as soon as possible. For example, they have a really clear idea of how many of the batteries need to be recycling, how many need to be the efficiency of the recycling of critical raw material, and also how many needed to be the concentration present in the new battery that will be put in the market with recycling critical raw material. This is really a big challenge, but it's also a really big opportunity I was mentioning before from Professor Colledani. For the preparation of the battery, we know very well that not only one field is able to do it. We need the engineering part, we need the digital part, and of course the chemical part. Me, as a chemical, I will give you maybe more an idea on what are the technology requirements for obtaining the critical raw material. And as was anticipated from the professor, his was the starting joint of University of Pavia and University of Milano Bicocca in the infrastructure of EcoCirc, where at the beginning of 2023 was inaugurated the laboratory Ercubat, located in the University of Pavia, where the main goal is the developing of sustainable and profitable recycling process that can have a perspective to be implemented also at more higher level and not only on a laboratory scale up. But of course, when we talk about recycling process, we have essentially two main actors and one new possible way. The traditional way for recycling critical raw material are metallurgical approach. Essentially, we can have two choices. The first one is the pyrometallurgical approach. It's the most simple. We need only an oven that is able to reach 1,000, 1,200 degrees, able to melt all the battery, and from the melt it's possible to obtain an alloy where we can find different critical raw material like cobalt, nickel, and iron, and after a leaching process it's possible to obtaining these elements. But as so simple as these techniques, it has a lot of problems. First of all, is the energy. To reach this type of temperature, we have to consume a lot of energy. Another one is the GHG emission. Of course, after 600 degrees, all the organic part of the battery present become a CO2 emission, and this is really a mess considering the perspective to have the less environmental impact process to be proposed. And also, not all the critical raw material can be recycled by this way. For example, lithium becomes present in the slag part, and this is quite difficult to be recycled, and also in terms of cost is really high, the price. So the hydrometallurgical approach, where, as say the name, now we are working in a aqueous solution by using strong inorganic acid like nitric acid, sulfuric acid and chlorhydric acid, we are able to leach completely the the active material present in the cathodic part, obtaining all the critical raw material in a liquid phase, and with a selective precipitation method, we are able to recover at 100% all the critical raw material. This is the most studied methodology until now in the field of recycling, because it shows really good efficiency. But the main issue actually is the using of strong inorganic acid. These type of solvents are really not cheap. Also, the using of strong inorganic acid have a really big problem in terms of environmental impact, because during the leaching we have the production of secondary toxic gas that needed to increase also all the price of the system to be implemented to do the leaching. But there is an opportunity. The opportunity of the last year is to study new type of solvents, maybe organic solvents that are more cheap and also with a really less environmental impact. And one of the most talked and most studied solvents in the last few years are the dipotectic solvents. For all of you that maybe are new this word of dipotectic solvents, these type of solvents are the combination between two or more components able to chemically interact each other with an hydrogen bond, and this type of interaction is able to decrease the melting point, and so we can find the composition in a liquid phase. Because it's liquid, we can use it as a solvent. And in some cases, it's possible to have, even at room temperature, the composition in a liquid phase. This, and in different studies, they show really good efficiency in terms of application. And one of these, maybe in the case when we have organic acid, it can be used as a leaching property. For example, here I reported some results obtained in the R2 bath by doing a dipeptide solvent with 3 components, where by studying the optimization parameters between the temperature, the time, and the power, because we use a microwave system for leaching lithium nickel cobalt oxide, we will be able, with a design experiment, to evaluate the best condition in order to extract at 100% all the free critical raw material. And because important word, closing loop, starting from the waste and ending on a new product, we precipitate all the single components, and with a traditional solid state reaction, we will be able to obtaining and also electrochemical characterize the second life cathodic material. Of course, the next step of this type of solvents is going to increase the concentration of material treated, and those in order to reach an industrial scale-up, so increasing the concentration of how much active material can be treated, and also to increase the volume rate. And the new method that's becoming really interesting, especially in the academic field for the recycling of active material, is the direct recycling. And direct recycling is totally different compared to the other metallurgical process, for essentially one thing. In this case, we are not going to destroy the active material, but we are doing a process that we can say a recharge. So one of the main causes of a battery that become a waste is because maybe the efficiency of the material has decreased because the molar rate, for example, of the lithium, that is the ion that is moving during the exchange process, is going to decrease. So the idea of the direct recycling is going to recharge the lithium ions inside the crystal structure in order to reform the starting one without destroying the starting active material. In terms of energy consumption, GHG emission, and revenue, this approach it seems to have a really good opportunity for the future. But now we are talking about a technology that is also in a laboratory scale-up. These are, for example, some results obtained even in the R2 bath, where we use LFP battery. I know that in the last few years, it's becoming really popular, this type of battery. We can think, for example, Tesla now is using only this type of active material, where by using a low melting salt of lithium, it was possible to reobtain the starting crystal structure of the lithium iron phosphate, and a really important point, also the carbon coating that is fundamental for the electrochemical conducibility of the material was preserved. And this is really a good result. Of course, as I say, this type of technology is in its first step, so in an academic level. The perspective for the future is going to be able to connect this technology also with the other step, for example, the engineering one, about opening the battery and be able to obtain information to understand which type of recycling is better to approach on the waste. And for example, in one of the European projects where we are involved, we are trying to be the chain in the middle between the laboratory scale-up and the industrial scale-up in order to understand how to put different type of technology in order to propose a closing loop way of treatment of waste. And talking about project, here are 3 main European projects where 3 Lombardia companies are involved that are really important also from a point of view where we have different type of TRL for each European project. For example, the first one that is coordinated directly from University of Pavia, Renovate, is, in this case, because we are at a much lower TRL, the main point is to try innovative technology in order to understand if there is a possibility to increasing and also reach more higher TRL. So the focusing is only on the recycling field. Moving on Automat, as I previously said, this is coordinated by us, ERP Italia Servizi. In this case, we wanted to try to find the best solution in order to connect the technology innovation with also a digitalization for a prospective industrial point of view. And last but not least, we have a more higher TRL, Batman, that was talking before my colleagues and also from the professor Marcello Coldani, that is the direct coordinator of the project, where there is the main goal to obtain the implementation of the first European circular battery valley. So from my discussion is all, and thank you for your attention.
Many thanks, Riccardo. Well, we can say that we concluded the first panel maybe 10, 12 minutes ahead of schedule, which was necessary because we are expected to leave the room just a bit before due to an organizational need. I will open a very short window for Q&A from the people in the room, if there are some. If there aren't, I am glad to continue speeding up on the schedule to leave more time in conclusion to take a look at the many samples that are exposed in that corner of the room and to discuss them directly with the referees for each project. So don't be shy if there are questions, if something to go deeper into respect to what has been shown. If not, okay.
Sorry,
Yes.
If I can say a last word from this project's point of view, I mean, we have tried to give you an overview of the results that our companies in the Lombardy ecosystem in AFIL are achieving, and the developments we can, let's say, develop together. If you feel like you have one or more points of interest with these projects, the companies, us, just send us an email. You will have contacts in the booth, well, in the close to the samples over there. I really hope that this kind of presentation that is very, you know, compressed, concentrated, informative, can be useful to foster the cooperation with local companies here, local research centers here, also due to the memorandum of understanding that was signed yesterday.
Yes.
That I think will facilitate this cooperation. And thanks, Dario, for inviting AFIL and these projects to be part of this.
It has been
session.
a real pleasure on my side. Thanks, Marcello, and all to the speakers. Now it's time then to leave the floor to the second panel, which is about, please, Ilaria, which is about green and sustainable chemistry, which is a rather broad issue, spanning from pharma and life science to science materials. But I won't take extra time. Please introduce the panel.
Good afternoon, everybody. So thank you very much for inviting us, and in particular, thank you, Lombardy Region and the Ministry of University Research and Innovation, was commitment to make this event possible. Thank you, Dario, for these opportunities for us. In these sessions, we will examine a set of tools and best practices that demonstrate how the strategic support of Lombardy regions enables the development, technological advancement, and the market deployment of biotechnology-based solutions. My name is Ilaria Re. I'm project manager at the Lombardy Green Chemistry Association, that is a point of reference of the Lombardy region for boosting bioeconomy and green chemistry. It brings together all actors active along the supply chains in different areas of specialization of chemistry, committed to support the green transition and making more a greener economy, including universities, research centers, and companies. So the case study presented today, we will showcase how policy instruments for ecological transition and regional innovation strategy can effectively accelerate the industrial uptake of new technologies, highlighting the ability of biotechnologies to transform local resources into high added value bio-based products, competitive and sustainable products and markets. At the core of my presentation is the value chain generator, AI, an artificial intelligence platform developed within the Symbio project, coordinated by the Lombardy Green Chemistry Association. The value chain generator AI is more than a tool, is a serve to digital backbones to interconnect all actors along the supply chain, from the raw materials to technology providers to the very end users, in order to help them in develop greener, more resilient, and more competitive business model. In parallel, we'll also explore VUROTEX, a patented technology promoted by a Lombardy company. Italbiotech will support the Lombardy region. VUROTEX exemplify how research industry can join forces to deliver innovative wastewater treatment solutions that significantly reduce energy consumption and emission, while offering a strong potential of replicability all over the world. Finally, this program will turn the transformative role of green chemistry in cosmetics, nutraceutical, and pharmaceuticals. Here, natural bioactive ingredient and clean manufacturing process ensure driving solution innovation. Finally, alongside the discussion, you can visit the exhibition Regenerative Vision, Like Matter and Heart by Luigi Christopher Veggetti Canco. You can see here one of these paints. There are many other +3 sculpture created with innovative and sustainable materials. All of these artworks are made by Artlight, and products made by the Blue Planet company, and a Lombardy company. Based on a mineral paint, uses natural photocatalysis, cut up to 90% of air pollutants, while improving indoor well-being. So we choose to combine science with art. This is the topic of the Italian pavilion, in order to show how our companies coming from Lombardy can be put in practice, and our innovation, their innovation, and having a strong impact in our lives. But now we can move. So if you want, you can find in the corner of the back of the room several products, including brochures and illustrative materials, and many catalogs of our companies. Then if you want to be put in contact with them, you can find all reference there. Now, I can move to this point in order to leave the floor to the video. And then, so maybe I can keep, no. So that's great. So let us now focus on Symbio, the European Commission funded project focus on make the industrial symbiosis real, and in particular by using the artificial intelligence tools. So the guiding principle of Symbio is quite simple, but yet transformative. What is waste for one company can become a valuable resource for another one. By applying this across regions and sectors, Symbio is creating circular value chains where residues become inputs for biopolymers, sustainable chemistry, and renewable energies. This vision is supported by the Vanguard Initiative, and in particular by Economy Pilot, that is a European association that brings together over 40 regions in Europe committed to use smart specialization strategy, policy instruments, to leveraging innovation and boosting innovation from lab to the market. Bioeconomy Pilot is led by Lombardy region together with the South Netherlands. And within this framework, Symbio project ensures the local innovation can be replicated and scaling up across Europe.
So Symbio's most significant added value outcome is the value chain generator AI platform, an artificial intelligence platform designed to build sustainable and replicable business model. The platform is one of the aims to tackle one of the greatest barriers to circular transition, not the lack of technology, not the lack of demo plans, but the lack of informations. Companies often don't know what waste or byproducts are available locally, or not they can valorize it. Innovators can face difficulties connecting with suppliers and markets. And this result is the fragmentation, so long development times and high level of risk. So the BCZ was created to bridge these gaps by integrating real-time data on biomass availability, technological processes, and market demands. Companies and regions can identify viable circular pathway. So the process begins by mapping biomasses and secondary raw materials across region. From there, the platform highlights opportunities to valorize side streams, showing how industrial byproducts can be converted rather than discarded. Finally, all of these flows converge into product development, where new bio-based solutions, ranging from packaging to cosmetic ingredients, are designed and connected to suitable markets. In this way, the platform links supply, technology, demand. It enables companies to clearly understand, first of all, what kind of resources are available, how they can be valorized, and which innovative products can be developed. This reduces uncertainty, lowers risk, and accelerates time to market. Beyond the operational insights, the artificial intelligence behind the BCG platform also provides strategical intelligence support. It allows, for example, monitoring technology in landscape, map pilots, demos, analyze the patent landscape, assess scientific publication and R&D projects, rely on robust data covering raw materials, valorization processes, product development, and market applications. So in summary, the platform delivers value in 3 ways. First of all, supporting the development of products from renewable raw materials, enabling the valorization of byproducts and waste, guiding design on circular products. In the video, you can show a practical example of what the value chain generator AI works. So consider, for example, an agriculture cooperative producing grape pomace straw. Traditionally, these materials might be discarded or just partially valorized for many other uses or turned into energy or many other products. Within the value chain generator AI, the cooperative can identify technology to transform these residues in packaging, materials, cosmetics, ingredients, and renewables. So the added value is, first of all, evaluate alternative scenarios. So the cooperative can evaluate at the same time multiple purpose targets. Secondly, can obtain valuable information regarding quantity and quality of the raw materials, who is the technology providers, and be in contact with technology providers able to scaling up the production, and finally end users. So you can optimize, so the cooperative, and then basically all users can optimize the information before starting investments. So within Symbio, the value chain generator is already being applied across 12 regions in 6 European countries. By 2027, the project will deliver 10 validated zero-waste business model designed with AI, tested in a real context, and ready for large-scale deployment across Europe and beyond. At European level, Symbio directly contributes to the Green Deal climate neutrality objective for 2050. At the global level, it provides a replicable model that can be based on already existing exchanges between Japan and Italy, and create new emerging opportunities. In conclusion, Symbio demonstrates how regional cooperation, digital intelligence, and green chemistry can transform circular economy from isolated initiative to a more systemic and scalable solution. So this is the end of my presentation, and then thank you very much for your attention. So I tried to reduce the time in order to be perfectly on time with the next event. So it's now my pleasure to introduce Mr. Maurizio Bettiga, Chief Innovation Officer of Italbiotech, who will illustrate the VuRotax technology. So please, Maurizio, the floor is yours.
Ladies and gentlemen, good afternoon. My name is Maurizio, and thanks, Ilaria, for your introduction. In fact, I'm Chief Innovation Officer at Italbiotech. I collaborate with the Lombardy Green Chemistry Association as a technical support to the coordination of the bioeconomy pilot of the Vanguard Initiative. I'm the Chief Innovation Officer of another company that has been presented these days. There is a brochure there, the ICT. And I'm also adjunct professor at University of Milan, where I teach patenting and technology transfer. And this might not be very interesting for you, but it is interesting for the story I will tell today. Because I'm here to tell you a story which is about sewage and a valley of death. But before anybody leaves the room after this, I'll tell you it's a nice story anyways. Why? Because it's a story of valorization or research result. Valorization or research results. It's a story of taking the idea that a person had. The idea was protected with a patent. A company found interest in such patent. A company designed a roadmap to take that patent from being a piece of paper worth the paper it was printed on, to something that companies now want to invest, to buy, because it's a device, it's a system. It's a system to treat wastewater, so sewage water, but also industrial wastewater. And this system is offering advantages. It is offering a return on the investment. So see, this is why I think it's a nice story. And the cherry on the cake of this nice story is that the Valley of Death, which is the place where startups die, has been passed also thanks to the collaboration with Lombardy region, also thanks to specific funding instruments of Lombardy region that the company has used to bridge this Valley of Death. So this was a little bit of an introduction of what I'm going to tell you today, and now I will be a bit more specific. And let me first elaborate a bit on this concept of Valley of Death and technology transfer. This is why, I told you that as a hobby, I also teach tech transfer. I do that as a hobby, as a teacher, but I do that in every day of my life because the business unit of my company is providing the services that are needed to transfer technologies from an idea to something on the market. Does anybody know in the room why it's called Valley of Death and why this is so deadly? So I will spoiler it, I will tell you. So it's called Valley of Death because it is indeed a level, a place in the roadmap of maturing a technology, maturing a project, where most of the projects fail. They get stuck there. There's no way out. Why is it so? Because it's the place in the trajectory of maturation of a technology where you have high risk and high cost. And if anybody in the room is an investor, this is the time to run out of the room when I say high risk and high cost. Because that is something that nobody wants. You have a non-proven technology that has just left the laboratory. Nobody really knows if it will work in real life. Pay attention to this. Nobody really knows if that thing is legal. Because this is what happens to research, likely. Because research is always ahead. Research is ahead of the needs. Research is ahead of the market. Research is ahead of regulations. And regulations are trying to keep up. So you have this technology You don't know if it works. And what do you need? You need 1 million or 2 or 3 to build a prototype, to validate it, to do testing, to show that it works outside of the laboratory. So it's like buying €1 million your lottery ticket. This is why it's called Valley of Death, and this is why their technologies get stuck and fail. And luckily nowadays there are policy instruments that support the companies. And supporting the companies sounds like charity. But again, if I talk about entrepreneurs' language, I call this de-risking. De-risking the trajectory of technology maturation. And now that I have spent almost half of my time giving you a lecture, sorry if it was boring, if you're more interested in sewage, then I will describe briefly our simple project. It is simple, technically speaking. It has not been very simple to bring it to the level it's now. So I will talk about our VROTEX. Our VROTEX is a system which you plug in existing biological wastewater treatment plants to make them more efficient. It is a system that allows the bacteria, which you see there, that live in wastewater treatment plants, to stay in the reactor, to stay in the basins. It is allowing the air that these bacteria need to breathe to transfer oxygen more efficiently. It is allowing these bacteria to be more concentrated. What is the effect of this? The effect of this is that to achieve water cleaning, you have to blow a substantially lower amount of air, and 50% of the energy bill of wastewater treatment plants comes from the electricity that is consumed by compressors. So that is a sweet spot to achieve energy saving. So the patented internal geometry of this device is allowing this. We didn't know that, we hoped. And how do? You build a prototype. So we built a 6 cubic meters, 6,000 liters prototype, which is what you will see at some point in the video. This is able to treat 1 cubic meter of water per hour. And how did we build it? This is the recipe. We built it as a plug-and-play piece of kit. And we did not want to use it. We gave it to the end users, to the managers of wastewater treatment plants. Sewage, so urban, industrial food, wastewater, and the beautiful, wonderful operations that you see there on the video, industrial wastewater from natural fiber staining, dyeing of wool, high-quality wool. Why? Because wastewater treatment is extremely refractive to innovations, because you go in jail if you fail, or almost. So to propose innovations, these have to be tested. They have to be tested by end users. So this is what the take-home message for you. If you are developing a technology, you give it to the end users to try. But build something that is not a toy. Build something that is also building trust. So this was our prototype, 6,000 liters, plug and play. You put it there. There is a hose that is pumping water upstream of the treatment, the existing treatment plant. It goes into the prototype. Another hose that is discharging the treated water upstream of the existing plant. So if it doesn't work, nothing happens. And you plug in the wall. This whole thing is 2 kilowatt rating because our system allows to treat water with very little energy. So we placed this in a plant, and we allowed it to work 24/7, 7 days a week for 4 months, 5 months, 6 months. Of course, taking samples in collaboration also with academic laboratories to understand what was happening, to analyze the performance, to validate. And the good news is that it is indeed working pretty well. So it is able to remove the same amount of pollutants as benchmark best available technologies with 40 to 50% energy saving. it is removing organic components, it is removing nitrogen, and it is producing less sludge, which is what you see there, which is also another substantial element of cost. And this all under the eyes and in the hands of the end users. So now we are ready actually to install the first industrial system in the production facility of one of the end users that has been using and operating our prototype. And of course, we are available to give our prototype to anybody that wants to test it, to build another one. In the meantime, we have built another much bigger one, which we are also testing, and to validate or evaluate industrial installations in existing facilities. And I have come to the end of my talk, and I thank you very much for your attention. Hope to see you around.
Thank you very much, Maurizio. And then we can move to our last speaker. So I'm pleased to introduce Mr. Luca Mattiocco, Project Manager at Consorzio Italbiotech, who will present another Lombardy region funded project. It's a Lombardy Health Bio project. Please, Luca, the floor is yours.
Thank you, Ilaria. Good afternoon, everybody. Today in my speech, I want to focus on the importance of green chemistry. So, green chemistry is not just a trend. It's a necessity for our planet's future. It represents a fundamental shift in how we think about manufacturing, moving from harmful processes to clean, sustainable solutions that work with nature rather than against it. So, let me start by painting a picture of where we stand today. The pharmaceutical, cosmetic, and nutraceutical industries face unprecedented challenges. Traditional manufacturing processes consume a big quantity of water, sometimes thousands of liters for a single product. So they generate significant CO2 emissions contributing to pollution. So these industries are under pressure from multiple directions. So consumers are becoming more conscious about what they put in and on their bodies. So climate change is forcing all industries to reduce their carbon footprint dramatically. But in my opinion, a very important challenge is that these companies must maintain the highest standards of quality and safety, but at the same time, they have to completely transform how they operate to reduce their impact. So it's like rebuilding an airplane while flying it. So this is where green chemistry offers hope, as it can reduce or eliminate the use and generation of pollutants. So it's about finding ways to create the same effective product through a cleaner and safer methods. So I invite you to think about this situation. So instead of using harsh chemical solvents, we can use biological and plant-based alternatives. Instead of using intensive heating processes, we can use enzymes that work at room temperature. So instead of discarding plant waste, we can transform it into valuable bioactive compounds. So the beauty of green chemistry lies in its potential to solve multiple problems. When we develop bio-based ingredients from natural sources, we are not just reducing environmental impact. We are often creating products that are more compatible with human biology and more effective in their intended function. So now we'll explore how this transformation is happening across different sectors. So in preventive medicine, green chemistry is enabling the development of nutraceutical products that provide health benefits beyond basic nutrition. So these products use bioactive compounds extracted from plants using gentle and environmental friendly processes. So the result is supplements that are both more powerful and more sustainable. In personal care, we are seeing a revolution in cosmetics. So traditional cosmetics often contain synthetic preservatives, artificial fragrances, and petroleum-based ingredients. So green chemistry is replacing these with plant-derived alternatives that are equally effective, but much gentler on both our skin and our environment. And in the end, the pharmaceutical industry is perhaps facing the biggest transformation. So drug manufacturing has historically been one of the most polluting industrial processes. So green chemistry is introducing new synthesis methods that use fewer toxic solvents, generate less waste, and require less energy. So, in my opinion, one of the most exciting aspects of green chemistry is how it enables complete traceability. So, when we use bio-based ingredients, we can track every single step of the process. So, from the field where the plants were grown to the final product on the shelf. So, this traceability is not just about transparency. It's about quality and safety. So when we know exactly where our ingredients come from and how they were processed, we can ensure consistency and purity in ways that were not possible with traditional synthetic chemistry. So thanks to Lombardy region support, this transformation has been made possible. The LBio project, funded by Lombardy region, represents exactly the kind of collaboration needed to drive this green chemistry revolution forward. So this initiative brought together small and medium-sized enterprises, research institutes, and universities into a powerful and effective innovation network. It's not just about individual companies trying to become more sustainable. It's about creating an entire ecosystem that supports green transformations. So the project addresses one of the biggest challenges. How small companies can access the resources and expertise needed to develop sustainable solutions. So by creating partnership between smaller innovative companies and large well-oiled firms, the project enables knowledge transfer and resource sharing that benefits everyone. So the project focuses on three main areas. Basic research, identifying new bioactive compounds from natural sources, including agricultural waste. Researchers are using advanced techniques to characterize these compounds and understand their biological activities. Then they are also studying the interaction between different bioactive substances to create more effective formulations. The second one is the development and production. So creating new products and optimizing manufacturing processes. So this includes developing probiotic formulations, extracting compounds from microalgae, and creating personalized nutrition products for specific population group. And at the end, the networking and scientific communication. So, building partnership and educating stakeholders about the benefits of nutraceutical products. So, this includes creating digital platforms for knowledge sharing and developing training programs for industry professionals. So, on the one side, we have small, agile companies. So, we can call the innovators. So, these businesses have a great value, flexibility, and the potential to develop breakthrough innovations rapidly. So they can experiment, adapt, and create novel solutions in ways that larger organizations often cannot. So they are the engines of innovation in green chemistry. On the other side, we have larger, well-oiled companies with something equally valuable: global commercial network, substantial investment capacity, and infrastructure to bring products to worldwide markets. So they have the necessary resources that small companies have not. So LBio project built a bridge between these two worlds. So it's not about competition, it's about a cooperation. So small innovative companies develop cutting-edge green chemistry solutions, while larger companies provide the investment and global distribution network to bring this innovation to market worldwide. So this is a fundamental point that makes this project innovative. So I invite you to think about what typically happens in traditional business model. So small innovative companies develop promising technologies but lack the resources to scale up production or access international markets. So they struggle to survive, and their innovation often die in laboratory. Meanwhile, larger companies have the resource but may lack the agility and speed to develop breakthrough innovation internally. So the Help Bio project is not just creating a supply chain, it's creating a cultural shift in how we business think about innovation and growth. So now I want to address something crucial, perhaps the most challenging aspect of this transformation. So we face a significant cultural gap in how we business think about each other. So for decades, the business world has been built on a model of competition. So companies see each other as rivals. So competition is the base of business culture. But this approach is holding us back, especially when facing challenges as complex as sustainability and green chemistry transformation. So no single company, no matter how large or innovative it is, can solve this challenge alone. So we need to overcome this cultural barrier and embrace a new paradigm, cooperation over competition. So the Help Bio project helped to bridge this cultural gap, demonstrating that when small innovative companies cooperate with large established firms, both become stronger. So the results of this cooperative approach are impressive and tangible. So the companies involved in Help Bio network have achieved remarkable outcomes that demonstrate the power of this model. Several small companies have obtained patents for their green chemistry innovation. So these intellectual property represent real competitive advantages in the growing market for sustainable products. But here is the key point. These patents were developed through collaborative research, sharing facilities and expertise that no single small company could afford alone. So, what does it mean for all of us? First, as consumers, we can drive demand for sustainable products by making conscious choices. So when we choose product made through green chemistry, we are voting with our wallets for a more sustainable future. For businesses, the message is clear. The transformation to green chemistry is not just an environmental imperative, it's a business opportunity. So companies that embrace this change will be the leader of tomorrow. And for policymakers and institutions, projects like Help Bio show the power of collaborative network. So by bringing together different stakeholders and providing support for innovation, we can accelerate the adoption of sustainable technologies. So green chemistry represents more than just a new way of manufacturing. It represents a new way of thinking about our relationship with the natural world. So instead of seeing nature as something to be exploited, green chemistry sees nature as partner and teacher. So the transformation of the pharmaceutical, cosmetic, and nutraceutical industries through green chemistry is not just possible, it's inevitable. So projects like Help Bio are showing us the way forward. So through collaboration, innovation, and commitment to sustainability, we create industries that serve human needs while protecting and enhancing the natural system that support all life. Thank you.
Thanks to Dr. Mattiocco for this stimulating conclusion. I think that there is time for some questions. And if there are not, I recommend not to miss the samples stored in the corner, maybe posing question directly to the speakers. As Marcello Colledani says, this has been a very quick overview of the possibility of cooperation between academia, institution, and enterprises. And I appreciate your patience in receiving all this packed information in 2 hours. However, I think that an important model emerged from what we heard. We can be coping with the challenges posed by our time, challenges about environment, energy, health, we can be looking for solutions based on science and delivering such solutions to everyday life through industrialization. And our responsibility as administrator is supporting the whole process with public policies and funding. I think it's something made from the bottom to the highest levels of collaboration, but actually we have a demonstration that work, and we hope that we have convinced you, if there was the need to, that this is possible for our common future. Thank you for your attention.
So I just want to thank you again, Dario, for hosting us and for Italian Pavilion, as well as the Lombardy region. From the Lombardy Green Chemistry Association, I just to remind you to have a look of the all materials you can find in the corner of this room. There you can find many samples and additional materials. And then please enjoy our exhibition, because it's very impressive, in particular for the impact of indoor well-being. You can see many hardworks around the Italian Pavilion and just in the ground floor. And then I would like just thank you very much for my colleagues, for Luca, Maurizio, Christopher, but also people that stay in Italy, Francesca, Matilda, that make this event possible. And thank you all for being here and for attention. Thank you very much.